Okay, now we just use a kind of a method as a plot in order to see that if I should say there has been some convergence in I should say the parameters for each individual parameters. Sorry, let me just close this email which I got for each individual parameters in our model. Now, the thing that we just want to do is that we just want to see that if there is no convergence just by looking, I should say, at the plots of our, I should say, the posterior distributions for each parameters that we have defined before, how we can see that the model has not converged. I'm just going to go ahead to just create a kind of a scenario for you as a demonstration. Non-convergence. Okay. For the case of the non-convergence, if we just want to talk about, I'm just going to come ahead and say, okay, I'm just going to go ahead with another model. I'm just going to call that model bad. Okay, for the model bad, which you're just going to have, and I'm just going to show you why I just called that this model is bad. I'm just going to go ahead with the same model which I had before as the stand. For the file, I just go ahead with the same stand file as I had before, woman.stand. And also for the data, exact the same thing. The data which I had, it was called data stand. And you notice that also, I hope that I didn't forget to just mention that. You see that with the stand functions that we have, that's the thing that it's very different from the linear models that we talked about that when we talked about the non-Bayesian frameworks. We saw that for the data, we take the whole data sets as a matrix and fit this into, I should say, the regression model. However, for the Bayesian context, when you use the stand model, then I should say in that case the data is going to be the data that you have designed it and you defined it for the stand. And that's the thing. However, before I just going to execute that line, I'm just going to just make some minor changes, which is going to be the number of the iterations. For the number of the iterations, imagine that I just go with the 500. Let's go with the 400. No, let's make it even much lower. 300. And also, for the warm-up, I know that roughly as a rule of thumb, it should be not only smaller than the number of the iterations which I have decided to have, but this is, as a rule of thumb, it's a half of the number of the iterations. Then it seems that the model now, I just call that model bad, is going to be ready to be executed, and I'm just going to, by pressing Control Enter, execute the line and see what happened. Okay, let's see, we just got an error message here. Okay, let's see if we just have, let's check the name of the data first. The data, it was data underline stand. Oh, okay. The reason it didn't work is that because I made a mistake. The quotation, it just went, I should say, at the wrong place. The quotation should just include the stand file which I have, which is woman.stand. All of it, it should be within two quotation marks, and the data which I had is the data stand itself, which I created here, and you see, that's a list of 3 items. And now, hopefully, things are going to be smooth and fine. Then I'm just going to execute the line. Oh, thanks God, you see that there is no error message, and it's just going to be executed, as you will see. We discard, I should say, those, the warning messages, and it's not, it shows that it's too low, I should say, the number of iterations that we had. You see that we had 4 chains, and we had, I should say, our samplings for 150 number of the warm-up, and the rest of the iterations was for the sampling. Okay, now we created a model which we call it a kind of a bad model, and now let's see, run the diagnostics for, I should say, this bad model. You know that you have to just use the extract function, which is specific for the stand function, stand package, by just putting, I should say, the stand file, which is going to be my model bad. And however, I'm just going to store that into an object. I'm just going to call that posterior bad, which is corresponding to a model bad. Let's execute the line, and you see that the posterior bad is an object which is created, and as you can see, it's the list of 4 objects, and each object is essentially all parameters alpha, beta, gamma, and likelihood that we have. We're going to talk about that a little later at the next tutorial then. Now, in order to show that the diagnostics from the plots that we have to do for each individual parameter, I'm just going to go ahead and do that. I'm just going to, first of all, as what you saw before, because I'm just going to do some plots, and I'm interested to have all the plots into one single, I should say, space, in one single, I should say, page. Then the thing which I'm going to do, I'm just going to create this MF row, which is going to be C equal to 1 page and 3 plots. And that's what it means. Par MF row equals to C 1 and 3. It means that 1 stands for 1 page, which includes 3 plots. If you have 4 plots, you can just put 1 and 4 there. I'm just going to execute the line by pressing Ctrl Enter and just go to do some plotting. The first plot is going to be for the posterior bad, that I'm just going to, I should say, just dive into to just select the alpha parameter. I'm just going to do as a plot. However, I need to just create an argument which it shows that it's going to be the main and it's going to be the name of the parameter, which alpha means that this plot relates, I should say, to the plot for the alpha. Let's do all together, then we run one by one. We are just going to have the plot. We have the posterior bad. Now we are just going to have this, I should say, the diagnostics for the parameter, which is going to be the beta. I'm just going to go ahead to create the name for my plot, and I call that it's going to be for the beta. And we all remember that the beta was a parameter which defined the intercepts in my linear model. And I do have also the plot, which is going to be again for the posterior. For posterior bad, I'm just going to just go ahead and select the sigma as a measure of this, the dispersion around the mean. And I need to just name that plot by, calling it only the sigma. Okay. We had, I should say, the line for the par, which now we are expect to see 3 plots in just one single pane or page. I'm just going to go ahead to have the plot as a divergence, I should say, or convergence diagnostics for the alpha parameter. Execute that, but also remember that I had to just put the type equal to L. And also the same thing for the other ones. Because with this type, which is going to be the, I should say, like the scatter plots, it's not very clear how the function, how the plot whether has been converged or not. Okay. Let's redo that again. Let me just clear this plot which I had. Let me just execute that line. Let me just go ahead for the alpha. Alpha seems has converged. The beta seems has converged. And the gamma, it also seems that they have converged. Okay, the convergence, it's not as good as we expected to have, but let's go ahead and run the iterations because the data was so simple. That's why we had also the convergence from there. Let's run, for example, the number of the iterations 50 and just go ahead with the warm-up as 25. It's gonna be, I should say, a very crazy model instead which we fit. And now let's see how, I should say, the plots should look like, and that's what I expected to have. Look at this. When the convergence has not been met, you expect to see the plot something like that. You do not have, I should say, that very compact, I should say, way to look into the plots for each parameter. And this type of the parameters, which you have for alpha, beta, and sigma, because I should say for the low number of the iterations that you have, it shows that the model has not converged. And that's the thing that we have to just stop here, and we cannot move forward to just run further analysis, because we cannot just, let's say, have any best estimates for the parameters. We cannot have, for example, inference for the problem that we have, and we cannot just do any, I should say, prediction for the unobserved observation that we just are interested to see their response value. Then we have to stop there. When we see these plots there, then it means that the model has diverged, the model has not converged. Then we have to just do some kind of parameter tuning. The parameter tuning that we are just going to do normally just goes with just increasing the number of the iterations or the number of the steps, which I'm just going to talk about that right now. For example, if you are just going to, let's say, for example, press F1, and if you just scroll it down, you see that, for example, you have many options you can choose. For example, we had the warm-up, we had many other items that we had to choose, and also if you just go scroll it down, you see that, for example, I should say, for some control measures that you have, for example, for the control measures, you have, for example, the adapt terms. These are going to be done. It's going to, essentially, we're going to talk about that more in details about the parameter tuning. But for example, in the control measures, for example, we had the step size, and for example, the step size jitter, and the metric, which are essentially a kind of a parameter tuning in order to increase the chance for the convergence of your method. We are going to talk about that more in details in the next tutorials, but remember, if the model has not converged so fine, they are the things that we have to do. We are going to talk about that later, but the thing that we do is that normally we increase the number of the iterations and also increase, I should say, or decrease, I should say, we are going to talk about that in detail, the step size and the step size g theta in order to meet the convergence. I think that's going to be a good point to stop. And the next tutorial, we'll just come back. We're just going to talk about the different methods, other methods that we use for the convergence. We're going to talk about the shiny stand and our statistics, which are just going to be a better option in order to check the convergence of your stand model then. Okay, and as I have always said, I can't wait to see you at the next tutorial.